Evaluate the definite integral using integration by parts. We're going from a lower bound of 0 to 1 of the integral of y over e to the power of 2y times dy. So the first thing we're going to do is we're going to let u equal y and dv is going to equal 1 over e to the 2y dy. And then we can write that as a negative exponent, so that's going to be e to the negative 2y dy. 2, we're going to take the derivative of both sides with respect to y, so du is going to equal dy. And then we need to determine what is the antiderivative of e to the negative 2y. So let's go ahead and do that. So if we want to find the antiderivative of e to the negative 2y dy, just use u substitution. We're going to let u equal negative 2y, du is going to equal negative 2 dy, and then divide by both sides by negative 2. So dy is going to equal negative 1/2 du. So here we have e to the u times negative 1/2 du. We factor out the negative 1/2, and now we're going to integrate e to the u du. So we get negative 1/2 e to the negative 2y plus c, and therefore there is the antiderivative. So we know that v is going to equal negative 1/2 e to the negative 2y. And now let's go ahead and evaluate. So step number 3, writing out the original question of the integral going from 0 to 1 of y over e to the 2y dy. And so the formula is u times v going from a to b minus the integral going from a to b v du. So we know that u is y, and then we're multiplying it by v, which is negative 1/2 e to the negative 2y. And we're going from 0 to 1 minus the integral going from 0 to 1. We know that v is negative 1/2 e to the negative 2y, and du is dy. Now let's just reorganize this just a little bit. So we have negative 1/2, which we can call as the constant, so it's going to be negative 1/2. And then we have y e to the negative 2y going from 0 to 1. Okay, now we're going to go ahead and then factor out the negative 1/2 times that minus sign, which is going to be plus 1/2. And then we can take the antiderivative of e to the negative 2y dy. Well, we know that we already found that e to the negative 2y, the antiderivative is negative 1/2 e to the negative 2y. So that's negative 1/2 e to the negative 2y going from 0 to 1. Okay, so now we have negative 1/2 y e to the negative 2y going from 0 to 1. If we factor out the negative 1/2 times positive 1/2 is going to give us negative 1/4 going from e to the negative 2y going from 0 to 1. So now let's go ahead and evaluate. So we have 1 times e to the negative 2 times 1 minus 0 times e to the negative 2 times 0 minus 1/4 times e to the negative 2 times 1 minus e to the negative 2 times 0. So we get negative 1/2 times e to the negative 2, and this is 0. minus 1/4. This is e to the negative 2 minus e to the 0. So if we distribute negative 1/2 times e to the negative 2, it's going to be negative 1/2 e to the negative 2, and that's plus 0 minus 1/4 e to the negative 2. Negative 1/4 e to the 0 is 1. So negative 1/4 times negative 1 is plus 1/4. And so then we can combine like terms. So we have negative 2/4 e to the negative 2 minus 1/4 e to the negative 2 plus 1/4. And then we can combine these terms. So we have negative 3/4 e to the negative 2 plus 1/4. And therefore that is our result.